I had a request to go over a couple problems in 16b. The first one, what is the concentration of sulfur in equilibrium with manganese sulfide? Here's the KSP, and the amount of manganese is 0.068. Okay, so let's set that up. So here we have this is a solid, and it's going to break up into its ions. So look here, the subscript on both of these are zero, or not zero, but 1. So you don't have to put a number, a coefficient in front of these, okay? What this tells me is that here at equilibrium we have 0.068 of manganese, and here we have, because it said, let me go back, in equilibrium. So at equilibrium, this is what you have. So this is your equilibrium value. So make sure you realize that's what that number is. Oops, wrong thing. Okay, so if I have the ice table, you don't really have to worry so much about ICE or ice part of it, just the E part, and the change here is going to be plus X. Okay, we don't have to worry about X right here because we already know this is 0.68. Okay, so here we go. We have 4.6 times 10 to the negative 14 equals 0.068 times X. Now I'm just setting up the K value. This is K. K is products or reactants. When you have a solid, you don't include it, so our products is this times this. This is X. We don't know how much it is at equilibrium, and we know this one here is 0.68. So if we plug this in and we do 4.6 times 10 to the negative 14 divided by 0.068, you end up getting 6.8 times 10 to the negative 13, which is your answer. Okay, and then there is one more. Which was, let's see, I think it was the last question. As it's loading, the reaction here is A, B, 3. This goes to A plus, notice right here, there's 3 B's, so I need to put 3B. I could put the charges, but it doesn't really matter mathematically. ICE. Okay. Let me see what I have here. What does the question ask? Oh, no, it's not last. It's number 3. Sorry. Here it is. So you have 0.0610 moles of generic salt AB3 is soluble in 1 liter. Okay, only that much is soluble. So that's your change. Okay. And what is the KSP of the salt? Okay. Right here. So my change, I don't have to worry about this because this is just a solid. Okay, I'm trying to find K. K is going to end up being A times B raised to the third. Why the third? Because of this right here. Now our change we know is going to be plus 0.061. This will be also plus 0.061, but this is going to be times 3 because there's 3 of them. So at equilibrium we have 0.061, and then here 0.061 times 3 is 0.183. Now I can plug all these values into here. So K equals to A, which is 0.610, times B, which is 0.183 cubed. So you put that in your calculator and you should get A is 0.000374, or approximately that, close to that. You could round it a little bit different. But notice we have 3 significant figures right here, and they had a 0 right there. So you need to also have there's a 0 there. 3 significant figures. So I think the big thing is figuring out the numbers they give you, where do they go in the ICE table?